And today is the 29th, I think. In 21, we have 21 on page 739, which is y squared equals 1 minus 2x squared. And it says, find the vertices, the foci, and eccentricity of the ellipse. Determine the length of the major and minor axes and sketch the graph. Okay. So first of all, I have to have 1 on one side, and both terms on the other have to be positive. Okay. So I will move to x squared plus y squared equals 1. I can't have a number in front of x squared. So I know how to handle this. This is a very, very important. I had difficulties with my calculus class understanding how to do this in limits, which is not something we do here. But so remember, 2x squared is the same thing with this. I copy x squared, I flip 1 over 2, and I get 2x squared. So this is a minor algebraic manipulation. When I divide by a fraction, I flip the fraction, and I get 2. Is that okay, everyone? Okay. Okay, so then a squared must be 1/2, and b squared must be 1.
So you don't divide everything by 2 or 1/2?
But if I do, then I will not have 1 on the side. Very good point. So here's, don't write anything because there is no need. So if I do that, if I divide both sides by 2, then I will have x squared plus y squared over 2 equals 1/2. And I can't have 1/2. Okay, let's review the equation of the ellipse. X squared over a squared plus y squared over b squared equals 1. Right? So that is the first step. I have to make sure that there is 1 on one side. And then I can try to manipulate the rest. Now, it doesn't matter how you want to look at it. Your book says that if they're switching the notation, I don't recommend it. Okay? So they say if A is greater than B, then A should be on the first spot. Okay? If A is greater than B and it's here, then it's on the y-axis. It's up to you. You should always look at the largest of the two. It doesn't matter if you call them AB or AB. It doesn't matter. Or BA, right? AB or BA. I don't want you to get confused on this. So the one that is larger, the ellipse will follow that. So for example, which one is larger, 1/2 or 1? Of course, so the ellipse will be on the y-axis, right? Because the larger number is under y. Okay, so then from here, A will be the square root of 1/2, and from here, B will be the square root of 1, which is 1. You could say, why don't you write plus or minus? Yes, I will have a positive A and a negative A. So for now, I will have a positive 1 and a negative 1. So this is the B. So B equals 1. And this one is negative 1. But I can't really write that, but it's fine. You can. So now I have to take the square root from this, and let's see what we get. So the square root of 0.5 is 0.71. Okay. So if this is 1, I'm going to say 0.7 is here.
So you don't have to rationalize that?
I need the approximation. Even if I rationalize it, I will still not be able to plot it.
Okay, because the book keeps rationalizing everything instead of that's why.
Right, but when you graph it, because the problem is also asking us to graph it.
Right.
When I graph it, I can't graph the square root of 2 over 2.
Right. Okay.
I have to approximate in order to graph it. Otherwise, I wouldn't need the approximation. but I need the approximation to graph it. So now here's the graph. So we're asked to find the vertices. So this vertex is 0, 1. This vertex is 0, -1. The length of the major axis, length of the major, is 1 + 1, which is 2. The distance between the lowest point and the highest point on the major axis. The minor axis, so minor, is twice the square root of this, right? To the square root of 2 over 2, because you rationalize it, right? So this is 1 over the square root of 2, and then you multiply by the square root of 2 over the square root of 2, and you get the square root of 2 over 2. But the length will be twice as much, the length of the minor axis, right? So this will be the square root of 2. So the distance between these two is the square root of 2. The distance between these 2 points is 2. Any questions? Are we okay so far? Okay, so now we have here somewhere an F1 and here somewhere an F2. So obviously F1 will have the coordinate -c, 0. The other way around, of course, sorry, because it's on the y-axis, sorry. So F1 will be 0, -c, and F2 will be 0, c, but I have to find c. And I know that c squared equals, which one of these two is the biggest? Because I cannot find 1/2 minus 1. It has to be 1 minus 1/2, right? The biggest minus the smallest. So this is 1/2. So if c squared is 1/2, then c will be the same thing, the square root of 2 over 2, right? So F1 will have coordinates. So from here, F1 will have 0, negative the square root of 2 over 2. And F2 will have 0, the square root of 2 over 2. Is this okay so far?
Yeah.
Okay, so let's go back to the requirements. Vertices were determined. Foci, yes. The length of the major axis, yes. The length of the minor axis, yes. Sketching the graph, yes. The eccentricity now. The eccentricity by definition is c divided by the larger of the two. So it depends, right? In this case, it's 1, yes. If you want to switch the notation, you can. So then the eccentricity is c divided by a. So c, I'm sorry, in this case it's b. In our notation is b. So c is the square root of 2 over 2 divided by b, which is the square root of 1, which is 1. So this is the square root of 2 over 2, and as we just determined, 0.707. Is this okay so far? Everything okay? Good. Next question, please. So we can move on from the ellipse. Anything else from the ellipse?
Can we do 19?
19? 1-9?
Yeah.
Yes, 19. So in 19, do we have to do all steps or just... Yes?
Yeah.
Okay. So 1/2 x squared plus 1 over 8 y squared equals 1 over 4. My first step must be getting 1 on one side. So I do have to do what then in order to obtain 1 on one side? Yes, I have to multiply everything by 4. So 4 divided by 2 is 2, so 2x squared. 4 divided by 8 is 1/2. And then I have 1. Is this okay so far? Yes? I will employ the same trick one more time. I cannot do anything here. This has to stay as is. So then I have a squared equals 1/2, and I have b squared equals 2. Therefore, is this ellipse on the x-axis or on the y-axis? Yes, it is again on the y-axis. So then A is the same thing, the square root of 1/2, which we just calculated the square root of 2 over 2. And B is the square root of 2. So this one is approximately 1.41. And this one is approximately, we just determined it, 707. So if we go ahead and graph the ellipse, so if this is 1 and this is 2, 1.4 is here. If this is 1 and this is 2, negative 1.4 is here. And then if this is 1 and this is 1, then I'm going to say this is 0.7 and this is 0.7, negative 0.7. So here's the ellipse. Can you determine the rest? Or you need me? Is that okay?
Yeah.
So one more time, you're going to determine the length of the minor axis, multiplying this by 2, so it's the square root of 2. You're going to multiply this by 2, so it will be 2 the square root of 2, right? The foci, you will have to determine c squared as being 2 minus 1/2. So it's 4 minus 1, 3/2. So F1 and F2 will have 0, 0. And this will be the square root of the negative square root of 3/2 and the positive square root of 3/2. And then the eccentricity will be C, which is the square root of 3/2, divided by the bigger of the 2, which is the square root of 2. And you will approximate it because it has to be between 0 and 1, and we get, so this is basically the square root of 3 over 2. So I got 0.866. Okay? Good. Anything else from the ellipse? We reached 33 through 44. Any questions on 33 through 34? Parker, I thought you had something there.
Yeah, 39.
39. Endpoints of major axis. Negative 10 comma 0 and positive 10 comma 0. Which axis is this on? X. Very good. So I'm going to say 2, 4, 6, 8, 10, negative 10, 2, 4, 6, 8, 10, 10. In other words, the ellipse has to go through these points because that's the major axis. Distance between foci, so I don't know where they are, but the distance is 6. So I'm going to say this is F1 and this is F2, and the distance is wrong. So if the distance is 6, they have to be right here. There is no other way. They have to be symmetric. They are symmetric left and right. So the distance between 0 and one of them has to be 3, and the distance between 0 and the other one has to be 3. Good. So this must be negative 3, 0, and this must be 3, 0, which gives us C. So we know that A squared is 100. I know that the ellipse has to have this form. I have this portion, which is 100, but I have to determine this one. And I know that C squared must equal A squared minus B squared if that answer is positive. If not, I have to switch them. b squared minus a squared. So c squared is 9. A squared is 100. So minus b squared. Obviously, I will get a b that is negative, so I have to switch them around. Okay? So I will say c squared equals b squared minus a squared. So then this is 9 equals b squared minus 100. So then b squared equals 109. And that's it. So the equation is x squared over 100 plus y squared over 109 equals 1. Do we understand how we got the equation?
So we put. Oh, okay, never mind. That was B squared. Okay.
So I wrote the formula as I remember it, right, as a squared minus b squared. But I cannot have any of these cannot be negative. So I realized that when I replaced a squared by 100 and I wrote minus b squared, when I move this here, I will get negative 81. Oh, actually it works. I'm sorry. I just didn't realize. I jumped into conclusions too soon. So 9 minus 100 equals negative b squared. That's perfect. So it's negative 91 equals negative b squared. So then b squared equals 91. Sorry about that. Sorry. So then b squared is 91. So this was 9 and this was 100. When I move 100 to the other side, I have negative 100 plus 9, which is negative 91. Both sides are negative. Awesome, which means b squared equals 91.
That was going to be my question.
Sorry about that.
The other one, the major was on, the bigger number was on under the endpoint where the major was the axis.
Yes, and it has to be that.
Okay.
Thank you. Yes. Yeah. So, yep. I should have written it. Always write it first and look at it then. Okay. Thank you. Anything else? Is there anything else that we want to go back to? I would like to solve one of the problems from 45 to 47. I know it's not required, but it's a very good practice. And if you have anything else, and maybe we can look at 55, which is an application. We should look at an application. So do you have anything else other than a problem from 45 to 47 and 55? Anything else? And then we move on to the hyperbola, okay? Yes? Okay, so please choose 45 through 47. This is useful even if we haven't selected it as a recommended problem. Which one? 45, 46, 47. 46. So this is x squared over 16 plus y squared over 9 equals 1. And an x squared over 9 plus y squared over 16 equals 1. Obviously, these two are what? What type of conic sections? We only looked at circle and ellipse. Of course, they are ellipses. Good. The question is asking us to find the intersection points of the pair of ellipses. Apparently, they intersect. How is that possible? Well, one could be this, and the other one could be this. Right? So it says find the ordered pairs and then sketch the graphs. We can sketch the graphs anytime and we know how to do that. But let's find the points of intersection. Any suggestions on how to find the points of intersection? You could, but then you still have x and y in the same equation. So I have to eliminate one of the variables. You could use the substitution method. Yes, you could do that. That's possible. Or eliminate fractions first, and then decide what to eliminate. Which of the x squared or y squared to eliminate. So if we decide to eliminate fractions, what will you multiply both sides by? Right, 144. Very good. So 144 both. Let's multiply both by 144. So then the first one will be 9x squared plus 16y squared equals 144. And of course, the other one will be 16x squared plus 9y squared equals 144. So first step, we eliminated fractions. Now we would like to eliminate one of these two, either x squared or y squared. So we have to make a decision which one. You either want to eliminate x squared or y squared. Which one? Okay, x squared. Well, what do we have to multiply top and bottom in order to eliminate x squared? The top by
0.
I can never multiply by 0. I need this product. So by 16 and by negative 9. Let's see what happens. 16 times 9x squared is 144x squared plus 16 times 16, 256 y squared, and 144 times 16 is 2304. Now I multiply the second one by negative 9. Negative 144x squared, negative 81y squared equals negative 144 times 9, 1296. So let's stop for a moment. Do we understand what happened here? And do we understand why I chose 16 and negative 9? I could have chosen negative 16 and positive 9. It would have made no difference. But is it clear why we chose that? Right? Because now this term, when I add it to this term, it will go away. And I finally obtain an equation in y alone. So 256 minus 81. 2304 minus 1296. Correct me if I'm wrong, please. And I divide by 175. And I got 5.76. And now I take the square root from this answer. And I got 2.4, but plus or minus, of course. I determined y squared as 5.76. Can I go back here and replace it and then get x squared? Is this okay? Are you with me, everyone? Yes? So with y squared, I go back to any of the two equations. It doesn't matter. Which one would you like to work on? Or first or top or bottom? This one? Okay, very good. So then I have 16x squared plus, I'm going to multiply 9 by 5.76. 5.76 multiplied by 9 is 51.84 and equals 144. And I get x squared by subtracting 51.84 from 144 and dividing by 16 and taking the square root and getting x plus or minus. You will see this procedure often. Guess what? I got 5.76. They are symmetric. I should have said that from the beginning. So then x squared equals 5.76, and of course x equals plus or minus 2.4. So now we will graph them, since we would like to see these points of intersection. But can anyone tell us how many points of intersection? Yes. When x is 2.4, y can be 2.4 or negative 2.4. When x is negative 2.4, y can be 2.4 or negative 2.4. So there are 4 points of intersection. So negative 2.4, comma 2.4, negative 2.4, comma negative 2.4, 2.4, comma negative 2.4, and 2.4, comma positive 2.4. in order to convince ourselves of this, so let's graph it. So for the first one, I have a squared equals 16 and b squared equals 9. And for the second one, I have a squared equals 9 and b squared equals 16. The first one is on the x-axis or on the y-axis? Good. So let's graph it. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. Here it is. That's the first one. And the other one is 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. How many points of intersection? 4. 1 in each quadrant. Very good. Let's continue with the window in 55. Any questions on this problem? We use the method of elimination. First, removing fractions, and then multiplying both equations by appropriate numbers to eliminate one of the two variables. We understand the procedure? Yes? Everyone, please? Okay. So let's look at 55. A sunburst window above a doorway is constructed in the shape of a top half of an ellipse, as shown in the figure. Okay, so I have to copy this. And we are given some measurements here. It's 20 inches tall at its highest point. 80 inches wide at the bottom. Find the length of the window 25 inches from the center of the base. So if this is 40, this is 20, 25, I'm going to say it's here. So we want to build this window, and we want to really put this little piece here. But we don't know exactly where to put it, maybe. Or we know that this is 25, but we want to measure this to see exactly where to put it, maybe. Or what is the length, and cut it such that it fits exactly between the center of the ellipse and this point. We want to determine this height. So we can measure this maybe, I'm not sure, I'm not a carpenter, it's hard for me to know what the steps are for them. But definitely this is a piece that we, for some reason, we want to put it in there, and we don't know exactly how long it should be. So for that reason, we have to determine this height. Okay? Good. So can anyone give us the coordinates of this point? Whatever you have. Yes, comma? Exactly, thank you very much. So if I manage to determine the equation of the ellipse, how will I determine the y-coordinate of that point? Plug in what? That's it. So let's find the equation of the ellipse. It's definitely x squared over plus y squared over equals 1. Over what? X squared over what?
Wait, wait.
Not this whole thing. So a squared is, this is a,
Oh, so
and this is a. That's why I put them already as 40 and negative 40.
40 squared,
That's it. And y squared over,
20.
that's it. So please plug in what now?
25.
That's it. Plug in x equals 25 and give me the height. Tell me what you get. Does it make sense? Okay. So 25 squared over 40 squared plus y squared over 20 squared equals 1. I would move 25 over 40 squared on the other side to the other side. I will not calculate anything. Just perform the algebraic steps. Multiply by 20 squared, and now with the graphing calculator, I will put this in and determine it. So the square root of 400 parentheses 1 minus 625 divided by 1600. Close the parenthesis and close the parenthesis, and I want the height. So what is the height? And I will not put plus or minus. So the height is 15.6125, and the measurements are in inches. .25 squared. Okay. Please double check my calculations. You don't have to put the squares already, just perform the raw calculation. So did we get the same thing? Okay, perfect. So that is the height. So knowing the height, knowing 25 and knowing the height, now he can measure and cut this accordingly. Assuming that that was the target. I don't know. Okay, ready to start the hyperbola? Okay. Here's an example of a hyperbola, and this is the way we are going to graph it. Same idea. We will put the A's and the B's like we did with the ellipse. We will create a box, a rectangle, going through all these points, going through negative A and positive A, negative B and positive B. Next step, we will draw lines, 2 lines going through this corner, the center, and this corner. Identical on the other side. Through this corner, and this corner. These 2 lines will be the asymptotes of the ellipse. And that's another one. two asymptotes? Yes, like the ellipse, it has two foci. Here's one. Here's the other. And now you can ask, are you going to graph the hyperbola finally? Yes, now I'm ready. But this is the preparation I need. The box, the asymptotes. If you graph, or if we're asked to graph the foci, we will. Otherwise, we're not required to. But now I'm ready to graph the ellipse. And the ellipse will touch this point, and will touch this point, and you will be closer and closer to the asymptotes. So this is how we graph a hyperbola. If you allow me to remind you one more time, every point on the circle will be found at the same distance from the center. Every point on the ellipse is found at a constant distance from the two foci by adding those distances, right? Here we subtract the distances. So every point on the hyperbola, for example this is the distance from F1. This is not part of the graph, of course. I'm just explaining. So this is the distance from F1, and this is the distance from F2. The longer minus the smaller will always be the same for any point on the hyperbola. So the brown difference, long minus short, will be the same different distance, the same difference, orange long minus orange short. This is a constant, like it was with the sum for the ellipse. The point on every point on the ellipse will be found at the same sum, constant sum from the two foci. Here, every point on the hyperbola is found at the same difference. That is the constant. Okay? So let's look at the equation. The equation of the ellipse, of the hyperbola, is very similar to the equation of the ellipse. What is the difference? Exactly. That is the only difference. It's minus. The other difference is that now c squared is much nicer. C squared is a squared plus b squared. The vertices of the ellipse, of the hyperbola, I'm going to still probably for the next 10 minutes, I'm going to say ellipse instead of hyperbola. Sorry about that. So the vertices are right here. This point and this point. Yes, the hyperbola can be on the y-axis. And here's the difference. If x squared has positive in front, the hyperbola is on the x-axis. If they are reversed and y has positive, if y has positive, then the ellipse is on the y-axis. Let's look at a few examples. Of course, that is called the central box. That is used to graph a hyperbola. On page 748, find the vertices, foci, and asymptotes of the hyperbola and sketch its graph, 9 through 20. So please choose. 9 through 20. We chose 15, 17 in the homework. That's what I have. It's recommended. If you want to choose from these, 15, 17, 23, 35, 31. If you want to choose from these, fine. If not, we choose anything else. Okay, let's start with 12. And then you can choose the next one. Square root of 2 minus y squared equals 1. Now it's very clear that the hyperbola will be on the x-axis. Very good. So then a squared equals 2 and b squared equals 1. Like before, a is the square root of 2 and b is 1. Let's graph it and then we'll find the rest. I have to start with the box. It's kind of difficult. The square root of 2 is 1.41. So if this is 1 and this is 2, then 1.41 is here. And 1 point negative, negative, and here is positive. And 1 and negative 1. So I plotted a, or negative a comma 0 and a comma 0, negative b comma 0, 0 comma negative b and 0 comma b. Now I have to create the box. Or the central box. So one more time, this is negative the square root of 2, and this is the square root of 2, and this is 1, and this is negative 1. I'm going to draw next what? The asymptotes, very good. And they have to go through this corner, the center, and the opposite corner. Can anyone give us the equation of this ellipse? I'm sorry. The equation of the asymptote. Remember, the height is 1, and the width is the square root of 2. Rise 1, run the square root of 2.
So 1 over square was square root 2 over 2.
So it's rise over run. That's the slope.
Yeah, so 1 over square root.
Exactly. Or the square root of 2 over 2x. Excellent. Perfect. And the other one must be the one with negative, right? So please anyone give us the equation of this. Yes. So this is y equals negative the square root of 2 over 2x. Because it's rise over run, but it's a negative slope. Ready to graph the hyperbola? So this is the vertex. As you see, it's not a function, as we promised. You know that. So we are asked to find the vertices. So the vertices are these. Negative the square root of 2 comma 0 and the square root of 2 comma 0. We were asked to find the asymptotes. We did. Here they are. This and this.
Will it always be opposites?
Which one?
The asymptotes?
Yes.
Okay.
Because this one has a positive slope and it goes to the same points. And this one has a negative slope and it goes to the same points, basically. Very good question. And now we want the foci. And remember, we have to determine C. Because the foci are like before, negative C comma 0 and C comma 0. So F1, negative C comma 0, exactly like the ellipse, and F2, C comma 0. But in this case, C is easier and nicer to calculate, not too much effort. C squared equals A squared plus B squared. A squared is 2, B squared is 1, so then C squared equals 3, which means C will be 3, the square root of 3, so the foci will be F1 is negative the square root of 3 comma 0, and F2 the square root of 3 comma 0. And it is good practice to plot them. So the square root of 3 is 1.7. So if this is the square root of 2, and the negative, of course, and this is 2, then somewhere here I have F1, and somewhere here I have F2. Any point on the hyperbola will have the difference of the distances between the further away minus the closer focus constant for every point on the hyperbola. Any questions on hyperbolas? Any questions? Do we need another one? Would you like to choose another? Is that a yes? Is that a no? Let's choose one problem from 1 through 8.
Wait, what was the hyperbola? Oh, that was F1. Okay.
The equation was given to us, and we were supposed to graph it, find the foci, find the asymptotes, and we needed to determine C in order to find where F1 and F2 are.
And those are
The vertices?
where is it?
Yes.
Oh, never mind. Sorry.
That's okay. Any questions? Let me see, where am I? Okay, let's find an equation from 21 through 24. It says find the equation for the hyperbola whose graph is shown. 21 through 24, you have 23 to do. Let's choose another. And let's also look at 31 through 42. Okay, I'll choose 22. Okay, so the graph in 22, so we are given a graph of a hyperbola. Find the equation for the hyperbola whose graph is shown. So let's copy what we have. Can anyone give us the vertices? It's 0, 12 because it's on the y-axis. Yes, 0, 12, yes, and 0, negative 12. These are the vertices. Can anyone give us F1? The coordinates are 0, comma 13, and F2, 0, comma negative 13. We know that the hyperbola has to look like this. Y squared over A squared minus X squared over B squared equals 1. How do I know? Because, yes, because it's not this, but this. Now you will remember the hyperbola forever. Good. So I have to determine A and B. Do I have A?
Yes.
I do have A. How much? Yes, or A squared. Very good. That's exactly A. The vertex. Very good. So this is y squared over 144 minus x squared equals 1. Excellent. How do I determine b squared? From here. Right? So c squared, which is 13, let's write this one more time. C squared equals a squared plus b squared. So 13 squared equals, yes, 144 plus b squared. So 169 minus 144 equals b squared. We know that b squared is so we found the equation of the hyperbola. Perfect. Now let's choose a problem from 31 through 42. You have 2 problems to look at there.
Is it 31?
You have 31 and 35. Let's do 36. Before you choose, I chose. But if you want to change, we can change. You want 36? Okay. So in 36, we're given the vertices 0 plus or minus 6 and asymptotes y equals plus or minus 1/3 x. Find an equation for the hyperbola that satisfies the given conditions. If the vertices are 0, plus or minus 6, it means the hyperbola is on the y-axis. Can anyone give us A? So, of course, the hyperbola in that case, once you tell me that it's on the y-axis, I envision this immediately. Right? Good. So, I already know that a squared is 36, correct? Good. So then we have that y squared over 36 minus x squared over, it's going to wait for a minute, so we can find b squared. Okay, so this information was used. Now, I know that the asymptotes will be like this. Rise of 1, run of 3. 1, 2, 3, 1. And then the other one, right? Okay, so knowing that, and the vertices 6. Yes, I have to do that because since it's 1, 2, 3, 4, 5, 6, then somewhere here it has to cross. Somewhere it has to cross this line. So whatever I have for the asymptote, this height has to be 6. So 6 over 18. 6 over 18 is 1/3. So then I know what? If I know that this is 6 and this is -6, and then I know that this is 18 squared indeed. How much? Very good. Excellent. Okay, before we look at shifted conic sections or rotation, in other words, shifted conic, we have to talk about the parabola. However, before we talk about the parabola, I would like to go to page 756. Page 756. And for now, we know 3 equations. So allow me to refresh your memory on 3 equations. And you will tell me which one is which. First one, ellipse. Second one, of course. And the last one, we'll add the 4th one in a minute. But I'd like to work on a few examples on problems on page 756. And then we'll come back to add the last one.
I have a question
question though.
Yes, please.
I've heard this on the last one we did. Like, how do we know it's on the y-axis? I know when we see
Because the vertices 0.
0.
Yes, 0, comma 6 is it's an ordered pair on the y-axis. If I were told 6, comma 0, the vertices would have been on the x-axis.
Okay, so the vertices is like the point where you
Yes.
the longest point. Or
Yes. So yes, very good question. This is the vertex,
Okay.
and this is the other vertex.
Okay.
Here, this vertex is a square root of 2, comma 0 because it's on the x-axis. Once I am told 0, comma 6, the vertex is here, and the hyperbola is here and here.
Perfect. Yeah.
Better? Perfect. Thank you. Okay, on page 756, I would like to look at problems 23 through 34. 23 to 34. Ready? Complete the square to determine whether the equation represents an ellipse, a parabola, we don't know that yet, I'll come back to it, a hyperbola, or a degenerate conic. A degenerate conic, although they should have included a circle here, they didn't, because they put the circle in chapter 1. What does that mean? It means not a conic section, maybe a point, or maybe an equation that does not represent a conic section. That's what it means. Okay?
He's ashamed of it.
Okay, so let's start with 27 on page 756. So regretfully, they did not put the circle in here, but I can make one up in a minute. Okay, so in 27 we are given an equation. 4x squared plus 25y squared minus 24x plus 250y and plus 561 equals 0. Like we did with the circle last time, we were given an equation kind of impossible to even look at, and we were asked, is this a circle? And we said, if I can put it like this, then yes. If I cannot put it like this, then no. So the same question here. But this is more difficult. Why is it more difficult? It's because there are numbers in front, different numbers, different than 1, in front of x squared, and in front of y squared. If you remember last time, we did not have that. We had some x squared plus blah, 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 or y squared plus blah, blah, blah. We did not have a number in front of x squared, y squared. I cannot complete the square with a number in front of the square term. I cannot divide by 4 either. So I will look at this term and try to complete the square by first factoring only from these two terms out 4. So this is 4 in parentheses x squared minus 6x. Leave some room and we'll come back to it in a second. Plus, now I have to look at, we'll come back 1 second. Now we have to look at this and this. What would you suggest to do first? Yes, I have to factor out 25 and I have y squared plus 10y and leave some room, please. And what else is left, and I have no choice but move this to the other side. Now this doesn't resemble anything at this point. Okay, now the middle coefficient is 6. I divide 6 by 2, I get -3, or yeah. Square that, 9. This is what I need, but there is no other side here. I have to do this locally. I'm adding 9 and subtracting 9 locally, right there, which is 0. I didn't do anything. Y squared plus 10y I get 10 divided by 2. I square. Good. Locally, what do I write? Exactly. Okay. Nothing happened, right? I put 0 in parentheses twice. Doesn't mean anything. Okay, now, I want you to give me this. I want you to give me this. And then we'll continue. So I have 4 outside. Please use brackets for a moment. And tell me what you write in parentheses. In brackets. What do you replace x squared minus 6x plus 9 by? We have an agreement from 3 months ago.
Or minus 3. Wait. Oh, x minus 3.
Yes. So it's x minus 3 squared. We have not done anything with this. We have to copy it. And please repeat for the second one with 25 outside and with brackets. And tell me what will you replace y squared plus 10y plus 25 by? And again, we have the same agreement. Y plus 5 squared minus 25 because we have not touched it yet. What do you think by simply looking at this? What would you say? Oh, I know what you're going to do next. And you will tell me. I must distribute. I must distribute 4 to these 2, and I must distribute 25 to these 2. I have no choice. Because I have some free terms that have to move to the other side. Ready? So this is 4. Quantity x minus 3 squared minus? Good. Plus 25 in parentheses y plus 5 squared minus 625 equals negative 561. We are much closer than we started, right? Now I have to combine these 2 and move them to the other side. So the left-hand side is 4, x minus 3 squared plus 25, y plus 5 squared equals. So please add 36 to 525 and put it to the other side with positive. And tell me what you get on the right. And I will do the same thing. So how much did we get? Excellent. Okay, so I'm looking at this. Can it be a circle? No, because it has numbers in front of parentheses. Absolutely not possible. Can it be a hyperbola? No, because it has no minus. What is the only option? The ellipse. But I have to have what on one side? Right. So what do I have to do? Yes. Write it like this first for everyone to see, and then let's simplify. Now I simplify 4 and 100 and I get and I simplify 25 with 100 and I get 4. So x minus 3 squared over 25 plus y plus 5 squared over 4 equals 1. One more time, what type of conic section is this? What is its center, please? Yes. So I shifted 3 to the right and 5 up. from the origin. Can anyone give us a squared? 25, okay, a is 5. And b squared? 4, which means b equals? Okay, let's graph it with a graphing calculator. I can't show it here because for some reason